Off we go. So I have a lot of things that I want to talk about in these slides. We will not finish them all today, but we'll get a good start. The first thing I want to say is make sure you're using that assignments tab on the zyBooks website to see which chapters, which sections of a chapter are part of your assignment. So you click on a link, it takes you to like the first section in that assignment. But if you come back out to the book, you just click the book's title up here. That'll take you to this table of contents page, and then on the right, there's a little assignments tab. And so you got the chapter 1 Xylab, all that fun stuff. Chapter 1, chapter 2, first part. You scroll down, you can see these are all the sections that I'm asking you to complete. And it should also show your score on the student side too. So that's what I want you to do. And you can see what I want you to do in the Xylab as well. All that fun stuff. So that's how you see what I'm assigning to you. Make sure you can see that. Do keep in mind, though, that only the due dates on Canvas are correct. I have to do a very weird thing on the zyBooks website so that it'll always transfer even if you do it late. So the due date on zyBooks is the last day of instruction. That is not your due date, right? That's so that it'll transfer if you do it late. Your real due date for like this one is the 16th. Okay, so just look at the Canvas calendar, and it will tell you the right due date. Hopefully that makes enough sense. So that's that. That's the zyBooks. Hopefully we've all been able to get the book, or at least ask the library or the bookstore nicely to give us a code. Alright, so the first thing I want to do today is talk about issues when you're programming, because I took a lot of care to spell everything right, do everything correctly last lecture, and I think that a lot of us, as we tried typing in the program that I had you try, like that hello world, we got errors from the compiler. It started yelling at us, maybe. Something was wrong. So the compiler is going to say some mean stuff to us sometimes if we speak C++ incorrectly. There are also other kinds of errors too, more than just that. So let's get into that. There's a few different kinds of errors that you're going to see during your computer science journey. The first and probably the most simplest is called a compile time error. Okay? So a compile time error is when you're speaking C++ incorrectly and you spoke it so wrong that it's not even going to compile. It's not going to do the right thing. The C++ compiler is like, I am confused. I don't even know what you're talking about. I cannot make machine code for this. Okay, so that's what a compile time error is. And it looks like I was supposed to not make this folder yet. So let me undo, zoom out. So I'm in the folder for our CSCI 40 lectures. I'm going to remove the one I just made. If you would like to know how to create your own folders, there's a terminal command for that. It's mkdir, M-K-D-I-R. Directory stands for folder. Same word, I guess. You say mkdir space the name of the folder that you'd like to create, and I'll make a lec02 folder for us today. And there it is. I'll cd inside of that, and that's where I'll work, and that's how I'll give you class. All right, that's what I was supposed to wait to do. Now we're back where we were. So let's make an example of a compile time error. I'll make a nice file called compileTimeError.cpp. So remember all your boilerplate, IOStream, include IOStream using namespace standard, get your main function, in between braces, return 0, always at the end. And then here is that int x equals 42. Yeah. So even my editor is being nice to me right now. But if I try to compile this, and G++ compileTimeError.cpp, if I press enter, it's like, int was not declared. Did you mean int? So it's nice sometimes. Like, all right, it highlights this is the line number 5. There's an error here. You probably meant int. And it's like, okay, cool. Yeah. And notice, if I do ls, it did not make a.out. It got so confused it could not make machine code. It could not make a runnable program. And that kind of makes sense, right? This is not a good program. It makes no sense to the compiler or to us. So that's a compile time error. Another kind of error that you'll see is called a runtime error. And that's when something bad happens, but the compiler is not smart enough to notice that it might happen, because it might not happen every time. So something bad happened while your program was running, and it cannot be recovered from. The program just has to blow up and stop itself. That's a runtime error. So sometimes those occur. The easiest one to show you is division by 0 for integers. That's an undefined operation. It stops the program with a runtime error if that ever occurs. So let me show you that. That will be a runtime error. So I'll make a new file called runtime. error.cpp. And this time, let me show you how the compiler couldn't know to like not allow this to compile. It's going to let it compile, and it's going to let it run, because sometimes it won't divide by 0. Let me show you my secret program here to demonstrate this. Let's make a variable called x, have it hold 42, and then let's ask the user for a number to divide 42 by. So enter a number, give them a little prompt, and then make space for a number to get from the user, and we'll get it with cin. Remember, the arrow is going the other way. And then what I'll do is I will output the result of dividing x by that n that the user typed. You see how the user can type a normal number, or they could type 0? And so obviously you want this program to run. You just want to hope that the user is going to do the right thing, but they could do the wrong thing. So let's compile this. Compile runtime error.cpp. And if I don't want this to be called a.out, and I don't usually, you can use -o, give it a real name. I want this to be called runtime error, just without any extensions. And so now that's the file that I'm going to go and run. /runtime error. And so I'll enter a number, 2. And so it divided 42 by 2, and so it printed out 21. And it ran to completion, everything was fine. If I run it again, I give 0. Then I get this ugly thing. A bunch of numbers, floating point exception, core dumped. This is just sounds very serious, right? That's a runtime error happening. All right, we're not printing this. That's the operating system printing that. So that's the program blowing up, and that's a runtime error. Okay, so this program compiles. It gets machine code made, and it starts running. If the user types the wrong thing, though, it stops itself. So that's a runtime error. Compiler is not smart enough to know that that might sometimes happen. It just lets it happen because it trusts you, the person who's going to run it. And so all this code down here, if there was more code down here, for example, when that division by 0 happens, it just stops the whole program. Nothing is going to get run after that. Okay, so that's a runtime error. The final error that is common in this class, probably the most common error, is called a logic error. Another word for that is bug. So that's the technical term for bug. And a bug in your program means that it compiled, it ran to completion, no runtime errors happened, it didn't blow up, it just didn't do the right thing for some reason. The result isn't what it should be, but the program just works. And so an easy example, I don't need to make a program separately, I can just show you on the slide. An easy example of a logic error or a bug is like, all right, I have the x variable, I'll store 42 in that, and then I will make a x plus 1 variable. And what will I put in that but x plus 2? So here's x plus 1. I'm going to store 44 in the x plus 1 variable rather than 43, like it probably should have been, right? So the program's going to run, it's going to finish, it's not going to divide by 0 or anything weird. It's just going to probably give you back the wrong answer because you typed a 2 instead of 1. See that? That's what it means to be a bug. Okay. And those are the hardest to track down because everything works, everything runs. And so you're going to get a lot of examples and experience tracking down logic errors in this class. But those are the 3 main kinds of errors. Any questions about those? Make enough sense? So nobody writes C++ perfect every time. Not even me. All right? We're going to run into these errors. They're just a fact of life. And we will recover from that. All right. So before I go any further and introduce more C++ and fancy operations and things, I just want to give you a demo of all of the things that we will learn in the next few weeks in this class, next several weeks in this class. So do not feel like you need to understand any of this because I'm about to say words that I have not taught you yet. All right? I'm about to speak C++ fluently to you, even though you're just learning the language. And so just pretend that you are young and you're learning your first language as a child, and this will make sense for you. This is something my Latin teacher at Fresno State did. She just started reading a passage to us, and we were beginning students, but it helped us get a feel for the language. So I promise it's worth it. So let's try this. I'm going to make a program that simulates, dun dun dun, a counting machine. Super fancy, I know. It's one of these little clicker things that you press and increments the count. And so we're going to have little operations to get out the count, look at it, reset it, increment it some more. So we're going to model this little counter thing in C++. Let me show you. Again, you do not have to understand any of what I'm about to say, but you can come back later once you do learn this and be like, oh, yeah, this makes sense now. But this is how I'm going to get you up to speed to understand all of what I'm about to write. I just want to give you a sneak peek, all right? So here's what I want to do. I would like to make a brand new type, not int, not double. I like to make a type called counter. So I can model a single counter thing, a single counting device. I want to have a type that looks like this, not int x, not int c for counter, but counter c. You can make your own types in C++. I'll show you that. And then I want to make sure like the counter starts out holding 0, because that's like when you open it up out of the box, that's what it should be saying on its little display. So the way that you can interact with this counter is by doing dots operations on it. So C dot, like initialize yourself, initialize your screen to 0, Mr. Counter. And then let's have an operation for pressing that button. And it's always, you're acting on C. So it's like C.inc for increment it. So that'll make the number on the screen 0. That'll make the number on the screen, 1. Now it's 2. Now it's 3 after all those lines have ran. Okay? And then finally, let's look at the screen and print out the count. C dot, let's call it get count as that operation. I'll just print that out. Ask it to look at the screen and shout out to us whatever that number is that's on it. So this is a very complicated idea, but it's essentially going to be a program that prints the number 3. See that? But we're going to model this counter thing as a brand new type. We're going to make a brand new type with the class keyword. So this is going to be a class called counter. This will make sense one day, I promise. And I'm just going to make, how many operations do we have? We have the init operation, we have the inc operation, we have the get count operation. So all those need to exist, and I'll make those in just a second. And then the piece of data that lives inside of every counter, it'll be hidden to the user in the private section. I'll call that just count. It'll have a little variable to itself called count that it's holding on to inside of its little counter called an object. And then, so all of these operations will be interacting with this little piece of data that it holds inside of itself called count. All right? So let's implement all these operations. So init, it just needs to run by itself. It doesn't need to give anything back. So it's a void function or method, we'll say, eventually one day. Inc just needs to act on the count, and so it can also be void. And then get count needs to finally give back the count to whoever's calling this operation. So it needs to give back an int. That's why we put the int there. So maybe you kind of understand what int main means now. It needs to give back a number. That's why we put an int there. All right. So init, what should that do? It should like zero out the counter's count. So count equals 0. Whenever we call inc, it should increment the count to make it 1 more than it used to be. So look at what you can do in C++. It looks a little weird. Count equals count plus 1. Let's make it 1 more than it was. Funny. And then get count needs to give back the count that's inside of this counter. So we use the return keyword to give something back. And so those are the 3 operations that exist on every counter type thing. And then they're all acting on this hidden count variable that lives inside. So that's what it means to make your own type and have some operations live inside of that type. And now this will compile and run, and it will like start out the counters, count at 0, make it 1, 2, 3, and then give back that 3 and print it. Again, don't expect you to understand any of this, but this is how far you will be going. Wow, it's a very fancy program that just prints 3. But yeah, that's where we're going. That's C++. We'll get to all that. All right. Any questions about any of that? I assume that you just want to wait and see what it really means. But that's C++ spoken fluently, more or less. Let's keep on trucking. Yeah, so the idea was I made my own type called counter. And inside of that, I had some data inside of every counter. I had the count that lives inside of it. And then I also had a bunch of operations associated with that type, like init, like inc, like get count. And those corresponded to the things that you would do to a normal real-life counter. Right? So that's how that all worked. And yeah, how fun. Now I'm ready to teach you stuff. Let's talk about variables some more. We talked about those a bit at the end of last time. So what is a variable? Let's go into that a little bit further. So a variable is just a box of data. It's stored in memory. It can hold a value. The naming convention is a little weird, though. Question first. I don't give you the slides before class. I could try to do that one day, but I'm not prepared to do that right now. One thing I can do is, this might be easier. I can start up Zoom if you want to have it on your screen, so you can. Is that better than looking up and down? If you go to my office hours link, there's like a class Zoom link. That one I don't have to like click to let people in. So how about I just share my screen on Zoom for today? And this is my class Zoom link if you'd like to go to that. There should be Zoom installed on these big computers, by the way. So there. I hope that's slightly simpler. If you just yell at me, I can give you a link later to my blank slides. All right. So variables. We said this, right? Int x equals 42 or something. That makes, let me get rid of this Zoom window. That makes a box in memory with the name x, and it holds 42 inside of it. That's what we learned last time. There are some rules to variables, though. Their names can only be certain things. You cannot have a variable with a space in its name, so like you can't say int x space y and have that be a variable name and have that be something. So spaces don't work. Variable names have to start with either an alphabetic character or an underscore, and then after that you can also use digits, so they can't start with a digit. So some valid variable names would be like underscore underscore hello, capital ABC underscore 007, stuff like that. So that is, those are variable names. And so if you can't have spaces, how do you separate words is the standard thoughts that you might have next. People have come up with two schools of thought for that. Like if you want to make a variable with multiple names, you can either use what's called camel case, where like it looks like the humps on a camel's back. You capitalize every time you have a brand new word to start, and so that's how you can separate them. Other people like to use underscores to separate their words. So either one of those are options for you. Pick which one you feel like at the time. So that's variables in a nutshell. I don't know why I can hear that still. It's so weird. I thought I muted myself. Whatever. Okay. I'll just keep on listening to that, I guess. Weird. So we have. Okay, I can't stand it. I'm gonna try and fix it now. Oh, there's two sounds right now. I see what it's doing. Okay, cool. So that's variable and naming variables in a nutshell. So what we did before, I showed you this. If you want to get something from the user and you don't have a value yet to put in a variable, you can just say its name and put a semicolon. You don't have to give it a value initially. And that's called a declaration of a variable. That's the part that actually makes the space in memory. So to declare a variable, you just say its type and you can just immediately put a semicolon. So this line by itself is a declaration, we say, of a variable. All right. And so the question, the $1 million question is, if I say this, and I then go and print X, what lives in this box? What would happen if I were to do that? Any thoughts? Any ideas? Maybe it's 0. That would be nice. Some special initial value. Maybe it's negative infinity or something. Smallest possible value. There are many potential options for a declared but not given a real value variable might hold. But the answer is it holds complete garbage. When you declare a variable and you do not give it a value, it holds a random value. It holds whatever is in memory at that time at that particular place in RAM. It holds nothing that you can care about, right? So if you ever want to use that variable in a normal way, you better give it a value. All right. So let me show you that. It's called I'm making a variable and I have not initialized it. So it's an uninitialized variable. So let's see if I can exhibit this issue on my virtual machine. I need to make a few undeclared variables. And we'll figure this out one way or another. So cout x. I might have to go to the class server for this, because my RAM does have 0 everywhere. So let's see if this works. Uninitialized vars, uninitialized vars. And so it's random. Sometimes it will randomly be 0 if you just started up your computer and it really was zeroed out at the time. You cannot bank on that, and let me prove that to you by running this exact same program on the class server, where it's been on for a while. It will take a second. I'm going to make another file, vars.cpp, holding the exact same code, g++ vars.cpp-vars. There we go. Random things. This is randomly the same value, and if you rerun it, the beauty of that is it's a different random every time, just wherever the program's getting loaded in memory, just reusing what was already in those places, in those boxes. So complete garbage. Oh, now we get some negative numbers. Cool. So do not ever use an uninitialized variable. It's gonna do things wrong. Right? Hopefully that was a good lesson. So what you should do is always initialize your variables first, so that they have a value and something that you can expect. Right? There's, I guess, two normal ways to do it. You can either say that it exists, and if you don't know what to put in it originally, you just wait, don't use x yet. And then you can say on a line by itself just the equals part. You can say x equals 42, and now it has a value. So like it started out question mark, undefined, random, garbage, and then you replace that with 42, essentially. That's what's going on there. Alternatively, if you do have a value for it to have initially, you can do what we were doing originally, int x equals 42, just do it all in one fell swoop. That works. I guess there's a third option if you take into consideration cin, so like int x, print out a prompt for the user, and then cin that variable, put something there. But I guess the name of the game is to always make sure that your variable is somehow initialized before you start printing it, using it in mathematical expressions, stuff like that. Otherwise, you're not going to get what you want. It's going to be random. You're going to be not adding to 0, but adding to like 32,000 something, whatever it was showing before. Okay, so that is, that's my warning to you, I guess. So that's variables, variable initialization, and uninitialization. What else do I want to do? I guess we can get into that now without another example. So that equals sign is called an assignment statement. If you say a equals b, a must be a variable name. Like it better exist somewhere. It's a box. And then if you say equals b, this could be some long expression like 2 plus 2 or whatever, or it could just be a number. But what happens is the b gets placed into the variable a. So this is what happens after that line completes. Right? That's called an assignment statement. And it's unfortunate that it exists and we use the equals sign. That's a bad choice in my opinion. Like the arrow would have been a lot better because you can change the value of a variable. If I have a variable x that lives here, and it holds like, I don't know, I set it to 42, and so it holds 42. I could come along later and say x equals 43 and replace it. That's no fun. That's not what equality means in math, right? Equality means if it's 42, it's never going to not be 42. Okay? That's why it's a little confusing. So variables can totally change in value, and you use the equal sign to do it, unfortunately. All right? I do also want to say that the right-hand side of this equal sign happens first. It gets run first. So whatever's over here gets run first, and then the result gets placed into the variable on the left. So if you have some long expression like 2 plus 2, it's going to make the 4 and put the number into the variable. It's not going to like leave it uncomputed or something like that. It's going to make the final answer. It's going to execute that statement. All right? So the right-hand side happens first. It gets placed in the left-hand side. Therefore, this makes sense now. Right? X equals x plus 1. All right. It does this first. What's x plus 1? Well, right now, if it's 42, so 42 plus 1 is 43. It computes that, and then it places the 43 in the variable called x. So that's another way to increment this thing. See that? That's so weird. Incrementing a variable is so common. People thought that this was too much typing, so they made a shorthand for it. Shorthand for adding 1 to a variable, x equals x plus 1, is x plus plus. And just use that on a line by itself with a semicolon. And so now you understand the joke. Now you understand why it's called C++ rather than something else. It came from C. It's like one better than the C language, I guess. Okay. That's the idea. There's even a third shorthand. You can say x plus equals 1 to add a certain number into the variable x. This is equivalent, again, to x equals x plus 1. But you can get x equals x plus 2 if you want to add 2 to it as well. That's a bit more general than the plus plus. But those are your options. That's assignment statements. You'll get used to it. You can reassign the value of a variable. Give it something new. Okay? Let's see, what else? That's good for now. Let's keep on trucking. I have a lot of terms to teach you now. So, expressions, literals, values, operators, so much going on here. A lot's just for math, but there's more to it now that we have a programming language on top of math. So a value or a literal, that's a basic piece of a type, a basic element of a type. So everything that lives in the int cloud, those are values or literals, things that you can immediately type, and those are whole numbers, right? -4 is a value, 0 is a value, 42 is a value. It's a literal as well. That's another word for that. So it's a value or a literal when C++ does not have to do any extra work to make it something in the cloud, okay? It doesn't have to add anything. It doesn't have to do any extra computation. When there is extra computation involved, you are not working with a literal, you're working with an expression. An expression is something that requires work. So it's any combination of literals and operators on them. So like x times 2 in parentheses plus 7, that's not a final answer. That's not an int yet. C++ has to do some work. Read the value of x, do the multiplication, do the addition to get a final int value back. Okay? So if I say int x equals 2 plus 2, again, that's going to make a box x, and it's not going to put 2 plus 2 in the box. It's going to execute this expression to completion, get a value back. That's 4. Put the 4 in the box. Okay? That's the difference. So I guess technically a value is a special case of an expression, but we don't usually think of it that way. So this expression, this big long thing, depending on the value of x, it needs to get evaluated to a value. Maybe it's 42. All right? So that's the difference. And that's the terminology. That's a good question. If you say x equals y, if you have another variable laying around. So I would consider a variable name by itself to be an expression because it needs to be looked up. But there might be different schools of thought there. Good question. Any other questions about this slide? This is just terms, knowledge. So I think we're ready to get into a very interesting concept that we need to talk about today before we do any other math. We need to talk about division in C++. I have dedicated an entire section of this lecture to division. It might surprise you that I did. It's worth paying attention to. So the division operation in C++ is the slash, and things are not as they seem. So I have a question for us. Let's get into our peer instruction groups. Please make sure you've signed in for the day. I'll keep that open because I know there was like an accident or something. So sign in. But once you're done signing in, go to the Buy Clicker page, and I'll start it off for us. Give us a couple minutes. Please say hello to the people around you. Get into peer instruction groups. Introduce yourself if you're sitting somewhere new today. But here are 2 lines of code, and I'd like you to ponder them. Try to execute them in your mind. That's what I care about you getting good at. You can go to the terminal if you want to, but if you have time. But here are 4 options. What do you think is going to be printed once these 2 lines run? Imagine that they're included in a normal big C++ program. Like this is part of main. It's like I'm not tricking you in that way. This code will run. It will compile. It's part of a bigger program. What's going to happen? You tell me. I'll give you a couple minutes. What do you think? All right. Take another few seconds, 30 seconds or so. Get your best guess in. I don't expect you to know the right answer. I expect you to tell me what you expect. Okay. I used expect too many times in that sentence. What are you hoping to have? What would be logical? All right, 5 more seconds. Get an answer in. 1, 2, 3, 4, 5. All right, let's see what we're thinking. We're all over the place, which is, that's why I'm asking this question. What do you expect to happen? It looks like not quite a majority of us are thinking B, but the most of us are thinking B out of any others. Let's try it. Let's try it. Let's see here. What do we want to call this? Division. That's CDP. So here are the two lines. Just put them right there. Division dash O division dot slash division is 2, not 2.5. 2, not 3, not a runtime error. The answer is A. Do we see why I dedicated a section of these slides to division now? All right. So, what is happening? Why? Why 2? What we just ran into was something called integer division. Remember that there's 2 different number types in C++. There's ints, which only hold whole numbers, and then there's doubles, which hold numbers with decimal places. Right? So division in C++ is slash, no matter what, but it operates differently on ints rather than doubles. Remember what ints look like. There is no room in the int cloud for decimal places, 2, 3, negative 42. Ints are only whole numbers, okay? And so if you do division on integers, division operates differently on ints than it does on doubles. So I just gave an int x and an int 2 by itself. There's no dot anywhere in that. That's an int still. It's an int literal. If I divide them, this division operator says, all right, I see 2 ints. I'm going to do integer division. And what that does is it just divides. It gets, I guess you can think of it as getting the 2.5, but there's no room for the 0.5, so it just chops that off. There is no rounding like you also might expect. It just chops off any decimal places. So like it computes 2.5, and then it chops off the 0.5 to make the 2. Okay, so when you do 5 over 2, that gives you back 2. The decimals are getting dropped rather than rounding, okay? So if you want decimal places, if you want the 2.5 like you might think it should be, you have to use doubles on at least one side of the slash. That's the thing. If you want double division, if you want the result to be a double and have decimal places, then you have to put one side of that slash, the type of one side of that slash better be a double, right? So double division depends on the types involved in the slash operations, not the type of the variable that's being assigned to. So it also might seem like if I were to do this, like double D equals, have I done this already? Let me do this separately. You also might think that this is okay, like int y equals to, let's say double y equals, double result equals x over 2. You might think that this will, okay, it's putting it in a double. Surely that's going to give me the 0.5. No, still 2. It's because at the time of the division. Remember, the right-hand side executes first. This is an int on the left. This is an int on the right. Still doing integer division. It's putting a 0.0 at the end. It has room for the decimal places, but it's not working. All right, so that's another thing to worry about. So, okay. It doesn't matter about the types being assigned to it. It matters about the types on each side. So if you give two ints, if you divide an int by an int, int/int, that gives you back int. That's integer division. If you put a double on one of those sides, it gives you back a double. So like the double can be the first thing. If you divide a double by an int, that does it right. That does your double division. Gives you back a double result. Okay? Well, that's the idea. So double has decimal places. It's known as a floating point type because it can work with, it has like 16 digits of precision, and really it's thinking in terms of scientific notation. It just doesn't show that to you until the numbers get huge, for your knowledge. So we got to make one of these sides of this operation a double. X is an int right now, so the easiest way to do this is to just make this 2 a 2.0. Now it's a double. Recompile, rerun. There's my 2.5. Cool. All right, so that's how that works. If you're dividing an int variable by an int variable, can't really change any of those, but you want the result to be a double, you need to convert one of those ints to a double. Like if you have this idea, if you have, let's see, if you have a variable int y equals 2, and then I want to be like cout x divided by y. Right now that's going to do integer division, but let's say we wanted double division. X is an int, y is an int, we're getting the 2 right now. You can convert an int to a double on the fly to, convert from one type to another on the fly by using the static cast thing. It's very ugly, but this is how you convert types of variables. You say static underscore cast. It's disgusting, but you'll get used to it. And then in between angle brackets, so like a less than sign and a greater than sign, in between that you put the type you want. So convert this to a double, please. Then you put parentheses around the variable you want to convert. So that big long thing. I'd like to convert x to a double, please. That's what that is. Static underscore cast to a double of x. All right? You can do that on either side. So let's do it to x. So static cast into a double of x in parentheses. So now the left-hand side of the division is this big long thing. That's x being converted to a double. Now one side is a double. And we get our 2.5. Okay? You'll get used to it. Any questions about any of that so far? That is integer division versus double division. If you want double division, one side better be a double. Still doing integer division. All right. Last thing on this slide is if you would like to print doubles in a cute way, there are some nice little helper variables that you can give to cout called fixed and set precision. So fixed lives in IOStream. You don't need anything special for that. If you want to give a certain number of decimal places when you print your doubles, you use set precision, and that lives in its own library. Stands for input-output manipulation, so IOmanip for short. We have to include that. All right, so include IO manipulation, and so this is for set precision. And these are little things that you can give to cout to control how it outputs doubles. So let's print the next double with 3 decimal places of precision. So that means, like, if it's 0.0, let's make it 0.000, something like that. So to do that, you the fixed and the set precision tag team. Fixed to make sure it shows the decimal place, and then set precision to make sure that it gives you as many decimals after that decimal place as you asked for. So it's a little variable. It's like a predefined library variable that you give to cout that just controls how it prints the next double. It's not really going to print anything. Say fixed to force it to do that, and then you say set precision to force it to give that many decimal places of precision in its output. Set precision, let's say 3, and then you can do your computation that computes a double. And now instead of printing 2.5, we are just now forcing it to print with 3 decimal places of precision. So now we see 2.500. And so if you were making like a program that runs a register, like you want to see 2 decimal places of precision most likely. You want to see the 250 for your amount on the screen. Okay, so that's what that is useful for. Fixed and set precision. They're little special helper things that you give to cout just like you're printing it, but it's really controlling the next thing that's being printed. Any questions about that? Fun stuff. Because that's all I really want to say about doubles right now. Let's see what else. Let's talk about characters now, the character type and the string type. So let's go there. At the end of the day, I should tell you this now, everything inside of a computer is secretly a number. It's all made up of binary at the end of the day. 1s and 0s make up everything that we store inside of a computer. So secretly, characters are numbers. Strings are longer numbers. So every character in the char type is really just a number, and your computer's just looking up what picture corresponds to that number really fast because it knows it was a char when it prints it out. All right, so let me show that to you. So it's a little weird to think about and wrap your mind around, but that's how computers work, right? So chars, that's easy. So let's make a program. Oh, I spelled it wrong. Get out of there. There we go. So if you see out a normal character, just like the A character, it knows that its type is char, and so it knows to show you the character. So we see the A printed, but we know how to convert between types now, so let's static cast into an int this character. Because it's just a number, let's see that underlying number. So apparently the encoding for A, the capital A character, is the number 65. Right? Kind of weird. Okay. They kind of go in order. B is 66, capital B. The space character is the number 32. But yeah, there's just a big long table that a bunch of people got together and made back in the 60s. They assigned every character to a number. It's called the ASCII table. All right. So you can look that up on Wikipedia, or you could look it up in the terminal. There's a manual page called man for ASCII. And so I can scroll down this, but here is the table. We're looking at the decimal row right now. These are the decimal numbers that you understand. So like the new line character is encoded as the character number 10. 32 was the space. There it is. The exclamation point is character number 33. Oops. The digits are a little weird. The character for the digit 0 is not 0. It is the number 48. Its ASCII code is 48, which is weird to think about. The digit 9 is ASCII code 57. Where are my capital letters? It's easier to read this table anyway down here. Which one is decimal? 32 is space. Cool. This one. So capital A, here it is. It's 50, or it's 65. 71 is G. Then the lowercase characters happen a little bit later. 97 is A, 98 is B. So every character has a corresponding number that was chosen for it. That's the ASCII table. So everything is a number at the end of the day. We know that. And that means you can do arithmetic on characters. Watch. So let's static cast into a char this time. Let's do arithmetic on A. Let's add 2 to A. They go in order, right? So this should be C. I don't want the number, I want the character when you print it, so let's static cast it into a character. Oops, I need to recompile. What is A plus 2 converted back to a character? It's C. So you can do math on characters. Isn't that fun? Alright, so that's usefulness. I think. Let's next talk about a bunch of characters. Those are strings. Those are things between double quotes. Remember those? So strings are made up of a bunch of individual characters. And that I need to tell you how to access each piece. All right? You can get at all of them. So let's say, let me make a string. Call it hello. If I make that in memory, you don't really think of it like this. Not just a box that holds hello. But instead of that, think of it like this little table. It is a bunch of characters that are separate from one another. They're just in order. That's really what S is. All right? It's the H character, then the E character, then the L character. They're all in there. And you can get at each piece through indices. Every place in the string, every character in the string has a corresponding index. They start at 0. We're computer scientists. They like to start things at 0. This is the 0th character. This is like the 1th character, the 2th character. I don't know. Weird ordering. This is really, so when you say go to index 2, you're really getting the 3rd thing. Okay? Just remember that. That's something to get used to in computer science. But yeah, if you want to get at an index of your string, you say s dot at. It's like you're acting on s. Like, hey, s, go to somewhere. Go to this place in you at the index you care about. So like go to s at 0. That will give back the h character. Okay, s dot at 1 will give back the e character. And you can use that to both get the value as well as set the value. So I'll show you that. Strings.cdp. So if I want to mess with string variables, I need the string type, which is included in the string library. And now I can make my string s equals hello string. That was a lot of the word string in that sentence. All right. So now I have my string called s. It looks like this in memory. I can access individual characters if I want to. I can print the whole thing. We know how to do that, right? See out s. I'll print the whole thing. There's my hello. I can also get at individual characters. So like s at 0, what's the first character? That's going to give the h. S at 1, what's the second character? That'll give the e. Just print it out on a line by itself. See how that's working? You can also use that same syntax. This could be the left-hand side of an assignment statement. This could be something that you put something into. You can put a new character into that index. So let me show you how to do that. S at 0, pretend that's like a variable. That's a place you can put something. That's the 0th index of the string. Let's make it lowercase. Let's set it to lowercase h. Isn't that fun? So now when I print s, it'll be lowercase hello. So you can use the same syntax to modify that index. You can both retrieve it as well as modify it if you put it on the left-hand side of an assignment statement. All right. Let's see what else. You can also get strings from the user. I don't know if I showed you that yet. I don't think I did. So let's just do that quickly. Or do I want to say that later? Yeah, okay, I'm going to do this later. Never mind. I'll get strings from the user in just a second. So this is accessing indices and modifying them. So it's dot at something, dot at something. Okay? Let's see. So I will give you... How do I want to do this? Here is a helpful screenshot, maybe. But I have a question for you now. Let us go back. Oh, man, it's not a Google Doc anymore. In the Written Ice page. Let's go to the Written Ice page on our class website. Again, Written Ice. I'm excited. Let's see if it works. But here's my question for you after we get there. Make sure you did attendance. I'll stop that in a little bit. But go to the Written Ice page. I'll clear it out for us. Delete. Oops. Woo. Delete. Did I click delete? Yeah. Refresh. Dun dun dun. I maybe just messed it up. Oh, darn. There was a bug after all. In that case, we really will go do a Google Doc in a second. Let's see. Yeah, I think I broke the class server, or the class website. Sorry. I'll fix that in a second. Actually, I should probably fix it now. I knew there was something wrong. www.logiclass.com. But at least, while I'm fixing that, you can discuss amongst yourselves. Who cares? You don't have to write it down anywhere. But what would you do? Oh, is it empty for you? Oh, cool. Yeah? Maybe it might be because you loaded the page before I clicked that button. If you refresh, it might not load. Oh, really? Oh, shoot. All right. Well, it's my problem then, but I'll fix it one way or another. But here's a question for you. If you can put it in the page, go for it. Here's a string. It's a weird looking string, but I'd like you to print A, B, C, D using this string. The characters exist everywhere. See if you can figure out the right ones. All right, so take a few minutes to try that. Use this kind of syntax and get it working. Dun, dun, dun. Yeah, apparently it is working. Just my internet, maybe. That's promising. Maybe if I disconnect from the internet, it will work. It thinks I'm connected though. Dun, dun, dun. Okay, cool. Yeah. I don't know what it was doing, but it figured it out. I guess we can see it and it will work. Yeah. But yeah, feel free to write it down. Write the code down if you can get it. What will print A, B, C, D? So where's the A? What's the index? That's what I'm having you practice right now. I'll give you like 2 more minutes to think about it. And feel free to discuss amongst yourselves. Argue about why your code is right. What is that A index? What is that B index? Maybe draw the table. Thirty more seconds. Give it a try. And can you have them print right next to each other rather than on separate lines? If you get it early. All right, let's take a look and see what we're thinking. 1620. 1620. All right, seems like we're confident that. Oh wait, no, some of these are not that. The rest are not. 1620 or 2731. I don't know. Let's figure this out. Dun dun dun. But yes, thank you for your participation there. What else? Yep. Let's just go here and let's draw it. So, what's the index of the D character? 0. Starts at 0. So the A is 1, 2, 3, 4, 5, 6. All right, so it's got to be C out S, and it's S2 now. at, let me draw S2 better, S2 at, the A is 1. And so you do that a bunch of times. Let's see out S2 at, what's the index of the B? It's 6. 6, let's see, 2, what's D? 0. So it's 1620. So good job to all of you who got that. Everybody else, I think you might have been off by 1. Just remember that those indices start at 0. Any questions about that? I think that is all I wanted to say on that slide. You can use CN, remember, to get a bunch of stuff from these. You can use it to get a number, an int, a double. You put it into a character variable. Whatever the type is, it'll get that. One thing to watch out for when you're reading things from the user and you want a string, you might think that using CN, reading into a string variable, will get just whatever the user types if they type a sentence. But it will not get a whole sentence. It will get only a word, sadly. So let me show you that. For some reason, they decided that if you would like to get just a word from the user, that's what you use CN for. So let's make a S2 variable. So enter a word, CN into the S2 variable, and then see it back out, I guess. S2 holds whatever's in there. So if I run this, it will only get a word from the user, unfortunately. So hello, it'll get it and print it back out. It's fine, it's happy. Whatever you want, whatever you put there, it'll get it. But if you start typing more than that, hello world, it only gets the hello. The world has not been read yet. Technically, you can use CN again. It'll still be there. It'll get the world that time. But that might trip you up one day. So showing you that now. If you want the whole thing, if you want everything the user types, instead of using CN, you use getLine with CN. There's a special, it's called a function, and it takes two things. It takes CN, where do you want the line from? I want it out of the user's keyboard. And then where do you want to put that line? You give a variable and it will fill it. So you make a line variable, and then you say getLine with CN into that line, kind of. It's part of the string library. So let me show you that. So I'll make a new file for that. Why not? So part of the string library for that. I also need to make a string variable anyway. So we like cout enter a line. And then we can start like making things. Make the line that we're about to get from the user, call it line. So string type, and then you say getLine. GetLine from CN into the line variable. And that will fill it. So what this does, gets an entire line from the user, including white space, including any spaces, the whole darn sentence, until they type enter at least. And from the user. All right. So I don't know. Let's just print back out what they gave us. So it'll be like cout you typed colon space and then whatever's in the line variable. So enter a line, hello, comma space world, exclamation point, 1, 2, 3, blah. Whatever's there, it's getting it all. That's what getLine does. Okay? So just keep that in mind. If you want the whole thing, use getLine. If you just want a single word, use CN with a string variable. That's the one weird thing. And yeah, any questions about any of that? I think I have one last example. Okay, final example. Let's bring together a lot of the stuff that we learned today. Let me show you how to capitalize a lowercase string regardless of what's there, regardless of if the user typed hello or their name, lowercase, something like that. So I'm going to get a lowercase word from the user, and our program, right, the user could type any word, so we are forced to have our program work for any string that the user types. So if they type hello, our job is to change that into capital H hello. If they type ABCD, our job is to turn that into capital ABCD, the first letter at least. So interesting. So we're forced to change the 0th index character to its capital equivalent, And let's figure this out. Let's figure this out. So, dun, dun, dun. If you look at the ASCII table, there is a secret. There's a way to do this. Here is the secret. Where is the lowercase character and where is its capital character? So here is, all right, it's hard to see. But here is lowercase a. It is ASCII code 65. If I was given lowercase a, 97, how do I make that 65? Like, I would have to subtract 32, yeah? 32 away from 97 gives me the 65, that is the capital A. The secret is they go in order. So B is 98, lowercase b is 98. If I needed to make that capital B, it needs to become ASCII code 66. I would still be subtracting 32. You see that? So regardless of the character, if I subtract 32 from it, that converts it to capital. That's the secret. So we noticed that the distance is the same. There's like a number line of ASCII codes that we were working with just now. Like here's the A character, here's the B character, and then way over here is the lowercase a, lowercase b. They go in order. And so the distance between capital A and lowercase a is the same as the distance between capital B and lowercase b. And so that's why you can just use that offset and just always subtract the difference between the two, which is 32. But if you didn't know that, it's just like if you knew that they were in order, how do you get the 32? Well, it's just capital A's ASCII code minus, lowercase a's ASCII code minus capital A's ASCII code. Just subtract them. You can use arithmetic on characters. Why not? So that's the secret. Hopefully that makes enough sense. It's kind of cool. Let's make that happen. Capitalize.cpp. So we're going to ask the user for a word. So I need to store it in a string variable. I need the string library. Cout. Enter a lowercase word. If they already type a capital word, it messes it up, right? It gives it a weird ASCII code. String word. So we're trusting the user here. But we're getting it from them. Cn into a single word. And now our job is to change the first character, which is the index 0 character. So we have to change word dot at 0 to something to itself minus that offset. So what's the offset? It's 32. If we didn't know that, we could calculate it by just doing lowercase a minus capital A, because they're just numbers at the end of the day. And that's our offset amount. And all right, take the 0th character then of word at 0. Take it, replace it with itself, whatever its ASCII code is, subtracted by that offset, minus dist, whatever's stored there. And this will work for any character. Cout word. Save it. Compile it, run it. Lowercase word hello. Capital hello, because lowercase h minus 32 is capital H. ABCD. Lowercase a minus 32 is capital A, capital ABCD. So that's going to work. And yeah, it'll work for any lowercase word that the user types. Any questions about that? It's a little weird, but that gets us thinking that everything's just a number. We're good with all that? Because that brings us to the end of the lecture part of today. And if we are happy, I will release your next lab, your first lab right now. And then this will usually be how we do things. I'll just release the lab, and then you can feel free to start working. Take your 10-minute break whenever you want to. I don't want to be in control of you. So let's do it that way. Has everybody said that they're here, by the way? I want to stop this. Okay, please do that while I'm releasing the lab then. All right. So here is lab 0. Of course, it's going to start at 0 in this class. And that should be available for you to see on Canvas now. So here is a write-up. These first few labs, I want you to complete them individually. I will eventually allow you to work in pairs, but not yet. I want you to get good at all of these things by yourself. All right. And so here is the write-up, the little PDF. I will open it, and then I will explain things. So the lab will be done on the class server. And so I've given you a bunch of programs that I want you to write. It will be fun. So yeah, so let me walk you through how to do this. It's getting recorded, which is nice. What else? Yeah, so let me log into the class server. Let me show you what I'm doing, how to do all this. Feel free to follow along if you'd like, but we'll come around and help you later if you're having any trouble. But here's your lab. Step 1, log in the class server. So server.loginsclass.com. I'll log in as my test student. And then let me clean out what I did for my other class. I want to show you everything from scratch. Step 1, once you log in, you're in your home folder, right? Step 1 is to go where you want to do your lab. If you would like to work in your home folder, stay there. If you would like to make like a labs folder or something, make your labs. CD into it. Get into the directory where you want to do your work. Step 1. Once you are there, I have made a gimme command for you to get the starter code for every lab. This one is very simple. It's just a bunch of blank files, but at least they're going to give you the right names. So once you're where you want to do your work, you say gimme space, then the name of the lab, lab00, that's like an email, @ CSCI 40. You hit enter, and it will download all of the starter code that I provide for you for this lab. Again, this one's just a bunch of blank files, but it will make a new folder for you inside of your current one called lab00. You'll CD into that. And now if you do ls, you see 3 files, and those are the 3 files you're going to work on for this lab. All right? So you'll just follow this, see how it's working. So your first step is to write a Hello World program. Very simple. I think you did it last time already. Let's do it again. That will be part of your credit for the lab. Not too hard this first time. So you want to edit the hello.cpp file. It's got to be the right file name when you turn it in. So just keep the same ones. And so what I want you to do for hello.cpp is I want you to write this Hello World program. But make it slightly fancier. Instead of just saying Hello World, I want you to say Hello World, ! I am ready for CSCI 40, ! And then a new line. So something slightly new, slightly different. And so when you compile and run, it should say this, and then a new line. So let me do most of that for you right now. So you can use nano if you want. Nano hello.cpp, let me do most of this for you. So include iostream using namespace standard. Again, use Vim once you get comfortable with it. Please do the Vim tutor. Cout hello world. I'll just do normal hello world because it's going to be wrong. I'll show you what it means to get it wrong and see on the autograder that it was wrong. So here is the file. It's incorrect right now. It's supposed to say more than this, but let me save it. Control X to quit. Do I want to save? Why? How do I want to save it? As, keep that same name, enter. So I've just modified the hello.cpp file. Now I can compile it with G++ -o hello /hello to run it. And this one just says hello world. So it's not yet correct, but it's getting there. That's your first part of this lab. All right, just make a hello world program that prints exactly this. You have 2 more parts to this lab. Your next part is to modify the cat.cpp file to print a cute little cat. It's got to look exactly like this. All right, and so when you run it, you should see this output. There are no spaces after the last character on each line. So after this \, there is nothing. There's no space like to keep it even or anything. You just break the line there. Break the line here. Break the line after this whisker, right? No space after it. Remember that if you want to print the backslash is escaped. Like it's waiting for something after. It's like \n, \t. If you want just to see a backslash printed, you have to escape it itself by adding another \. So you got to print 2 backslashes. Type 2 backslashes to get 1. All right. So make your cat look like this. Make it all pretty. New line after the last line, of course. And that's your second part to the lab. And then your final part of the lab. By the way, are there any questions about the cat? I think hello is kind of self-explanatory. Does the cat make enough sense? Go to the last part. All right, so last part of your lab is to write an average program using integer division, so you don't have to worry about static cast or anything like that. But here's what I want you to do. I want you to write a program that looks exactly like this when you run it. Exactly like this. You are going to, it's called, here's the file name, average.cpp. It is blank right now. You got to fill it all in with a program that does this. It has to show 3 prompts to the user, right? Type the first number, type the second number, type the third numbers, because you got to get 3 numbers from the user. It is the user typing the 7, the 10, and the 15, by the way. They're also pressing enter. So just compare against the screenshot. Don't have any extra lines. Don't print the number twice. It's the user typing the 7, the user typing the 10 here. This is just an example run. The user's typing the 15, right? Your job is to print the prompts on each line and to get those numbers. And then you take those 3 numbers that you just got. I assume you're putting them in variables. And you compute the average. So add them all up, divide by 3, because there were 3 of them. And you're using integer division. Don't worry about like printing decimal places. But calculate the average, print that, and then the average was that, period, is what you print out. Okay? So your job is to output a bunch of prompts, type the first number, colon, space, blah, blah, blah. And it's the user's job to type the number and press enter. Not your job, right? Not you as the programmer. The runner's job. So try it out, make it work like that. Try with a bunch of different inputs. But with these inputs, it better look exactly like this. If you type 7, enter, 10, enter, 15, enter. Okay? So that's how that should work. And that's what I want you to do. It's probably the most complicated program for the lab. So maybe do this one last. Are there any questions about this one? So you're getting 3 numbers from the user, printing out the average. The output needs to look exactly like this. All right. So compile it like that, run it like that. And once you're done, or if you want partial credit or whatever, you are ready to submit your code. All right. You're going to submit on the terminal to the auto grader that I have made for the class. Here's how you do it. You get into the folder where you're working, where all the code is, all these files are, and you're going to use the turn-in command to turn in your work to the class server. You say turn in, and then just like when you use Gimme, you say the name of the lab that you want to turn in. So lab 00 at CSCI 40. And then after a space, you space separate all the files that you want to turn in. So you can just turn in some if you want, but it's best to just turn them all in because the auto grader is going to use your last submission as your grade. So it's best to just always turn everything in, even if you haven't done them all yet, just so that you get in the habit. Because like if you do one, you only turn that one in, and then you do another, you only turn that one in, you just lost credit for the first one. You have to turn them all in at once. The last turn in is your grade. Okay? So just keep that in mind. So that's the turn in command. You press enter, and in theory, it might take a few minutes because other students are submitting around the due date time, but it'll show you like this. It's like submitted, starting the grading. You can keep it open while it's grading. It should take like a minute or two in theory. It's like, all right, finish grading, uploading the grade to the class website. It did it. All right, we're done. Press Control-C to get back to the terminal, and it graded your assignment. So after you do that, there are 2 ways to look at your grade. The ugly way is in the terminal. I don't recommend it very much unless you really need to look at it this way. But there's a view grades command that I made if you just want to look at it very quickly. See if you got 100% or something. But if you press enter after typing view grades, it's a very simple program that I wrote to view your grade in the terminal from the auto grader. It will give you a bunch of options. The most recent option, they're all numbered, is going to be your most recent submission. So option 0 is probably what you want. I have 2 options because I did this for another class before now, but you're just going to see option 0. So you'll be like, all right, I want to view grade number 0, hit enter, and then it plops open your score file. And so this is as pretty as I can make it on the terminal, but you can use the arrow keys to go down and take a look at it. But like you got 0 out of 9, darn, because you didn't do 2 programs, and the first one, the Hello World program, wasn't what it was supposed to do. It wasn't saying all that it was supposed to say. Okay? So that's how you'd view your grade. The rest are like, it didn't even compile because there was no main function. You can type Q to get out of that, but I would rather you look at your grade on the class website. It's prettier there. So let me show that to you. So if you log in on the class website, which I assume you already have, I'll log in as my test student. You can go to the lab grades. That's where it's getting uploaded. And so you'll see lab 00 at CSCI 40. You'll click on it. And this is why I want you to do it here. Look at the color coding. I've made this nice for you. Okay? You see your grade. It's like, oh, why did this not work? The plus and the minus are not part of your submissions. It's just trying to say, if you subtracted this line and added this line, it would have been correct. But here is your output. Like, here's what your program did. It said hello world. And here's what it was supposed to do. Do you see how that's very helpful? It's highlighting exactly what you need to change. The auto grader is very picky. It has to be exact, but at least it's going to show you what it wanted. All right? And then the rest are like, it didn't compile because there was no program. All right, so that's how you view your grade. And you can submit as much as you want before the due date. Your last submission is your grade. Question?
So if we use the turn in command, we want to turn in each file individually,
No, you have to turn in space-separated files. That's how the turn in command works. It wants every single individual file that you're trying to turn in right now. Because that folder contains compiled code and that gets large, and I don't want to save that. Yeah, that's why I'm doing it this way. But that's how the turn in command works. You got to give every file that you want to turn in. That's how that works. And then, like, here's the rubric. They're all worth the same amount. Yeah, turn this as much as you want before the due date. Get it working. The autograder is very picky, so if you're missing a space, you're missing a new line, it will give you a 0. But hopefully it will highlight the problem and you can fix it on the next round. All right, that's the trade-off. You get instant results, though. Any other questions about the lab before I let you go off and work on it? All right, that is all that I have for us.